Well, let's start to dive into this section now. The first one probably won't have anything to do with what we do for a couple videos, but it'll come in handy later. So as we move in, I need you to drop everything you know about trig so far. Just drop it. Drop it right now. We're going to just define things a little bit differently and just hang on. Just hang on right through it. We're just going to define things. So just let it go. No SOHCAHTOA, nothing like that right now. Just, here we are. Oh my gosh, there's so much shit written there. So I'm going to do some stuff to help us out. Go. Just for now. Just for now. Just get out of here. 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 Okay. Try to get rid of some of the noise, because there's a lot of noise that's going on, and we'll start erasing that. We'll talk about it. We won't hide from it forever. But what we're saying now is that sine of theta is equal to some y value over the radius. And now let's look at our picture over on the right. Now, why we're calling that thing r, just to get you an idea. Maybe about that big. You know, the radius of a circle, that's why it's called r. All right, so don't stress. I'm gonna get rid of that thing though. All right, that's why it's called r, like the radius of a circle, because this thing can spin around in a circle. Ha, get it again, I said circle. Look, no matter where we put this little, the terminal side, no matter where we put the terminal side, it's still gonna have that same length, okay? Right, that's how a circle works, same radius everywhere. Cool, cool. And then we have, of course, if we go into here, maybe it's like your x value is going to be -3, and your y value is going to be 1, 2, 3, 4, 5, 6, 7. Okay, so you're like your xy value is -3, 7. See, this is still the xy, right? So that's why it's giving you that point right there. So let me get rid of the numbers and actually write in how it should be. Ah, shit! What just happened? Yeah. Thanks. I've come too far. I'm not backing up. We're pushing ahead. All right. So let's get rid of all these numbers right here and just say that these points, this height's y, this distance is x. Okay. And we're claiming now that sine of theta is equal to y over r. Y over r. So wait a second. Let's see if we can't tie that together. What if I just drop this thing down? Just did this. Oops, I kind of missed my mark. I'll make a bigger one. I think I just made a right triangle. And what this is claiming on this right triangle I just made here is this is the radius. The y value, that's the height. That's the height, right? So that represents how far it is from here to here. Or from here to here, yeah? So that side on the left, we could say that this is y. And we could say, oh, down at the bottom, if that's x, if that's how far our x value was from the axis, then that means this length here needs to be x. Well, that x is actually a negative value, but whatever. We're going to ignore that for now, okay? Don't trip about it. Now, notice how the angle is written outside. It's over here. What if we put an angle here? I'm going to call it something different. I'm just going to call it alpha. What the hell? I'm sorry about the notation. I told you hang on. Hang on. Couldn't we say, now let's match up sine. Let's say sine of theta from up here, sine of theta. But let's say we're looking at this. We're calling that thing theta. Wouldn't it be the opposite over the hypotenuse? The opposite over the hypotenuse? It would be. That's why these things are set up like that. Okay, now I'm going to jump back out of it.
I just tried to jump in, show you like, oh, maybe real quick. We go, well, what's cosine of that number? We jump back, we look, we get rid of all of that crap. When we go cosine, that's just the x value, whatever the x value is, divided by whatever the radius is. Or the way we're looking at that, our x value is our adjacent side, and the radius is the hypotenuse, which is exactly what cosine is. So we're going to get that x over r. And take this with you for the rest of the frickin' trigonometry. Cosine goes with x. It's not necessarily x, but it goes with x, and sine goes with y. It's not necessarily y unless the radius is 1, and then we're talking about the unit circle, which we will have a video just on building the stupid-ass unit circle that we're going to use like crazy. I talk smack on it, but gosh dang is it useful. I just don't want you memorizing it. I want you to learn the tricks, so you don't have to memorize it. You only have to memorize a few values. Okay, back to it. Let's get rid of all of this. Let's read it. So, just for now, we're going to play the game. Whether you understand it or not, let's just play the game. Let's see a problem and say, let's say we have a point, and let's put our point at, let's put it at 3, 4. All right? Let's put that thing at 3, 4. Now, what I'd like for us to do is, let's go find out what sine of theta is, what cosine of theta is, and what tangent of theta is. Just from a point. All right, wait, zoom back out so we can see. Oh, shoot. It's talking about that we can go through, if we know our x and our y value, we can find our radius. Because, dude, again, it's just a right frickin' triangle. It's just a right triangle. It's a right triangle. A squared plus b squared equals c squared, the frickin' radius squared. So when we set that thing up, we're looking, we're like, it's because x squared plus y squared equals r squared. You hit it with a square root on both sides, and there's your formula over there. And it says don't let that shit equal 0, because then we're not talking about a triangle, and none of this makes any sense anyway. Okay? And you're not allowed to divide by 0. So let's find out for our problem here. Let's see if we can't go find sine of theta, cosine of theta, and tangent of theta. Let's make ourselves a little... Let's pop in 3, 4. Where do you want to put it? 3, 4, so maybe up here, you just call it 3, you call it 4. And then let's play connect the dots. Where this thing's the radius. And then our xy value is 3, 4. So we got to find out what that radius is. Good thing we have a formula. But I say F that formula. But that's just my style. I say just drop a perpendicular and just go, bro, 3 and 4. 3 squared. And now we have a squared plus b squared equals c squared. It's the same formula as that r is equal to when we're trying to find it. Oh, shit. I mean r. Did I say c? Oh, dude, I'm so sorry. We're trying to solve for r. I called it c because it's the same freaking thing. So we pop it in our a. We can call it 3 squared plus 4 squared is equal to r squared. So that's 9 plus 16 or 25. So it looks like r squared is, r is going to just equal, r is just equal to 5. And we're going to keep the radius positive, okay? You're going to get a choice. You choose. Do you want a positive radius? You want a negative radius? Let's keep the hypotenuses, hypoteni? I think it's just hypotenuses. So the hypotenuses and the radius for now, let's keep it all positive, huh? Always, let's just keep it positive, keep things cool. So we find out that this is just equal to 5. Our radius is equal to 5. So we have our x and our y, and we could have just used that formula and got it. And we go, all right, well, sine is equal to y over r. All right, well, that's what, 4 over 5? 4 over 5. Cosine's x over r, so that's 3 over 5. And then tangent, oh, remember that game? 4 over 3, that's the answer, 4 over 3. Because it's just going to be, where's it say? Oh, it's just the y value over the x value. All the same rules still hold. It's just we're going to have to start looking at trig a little bit differently. we're going to start placing triangles in different quadrants and having to solve them. And we're going to have to make do with the fact that sometimes they're going to have negative values. I'm staying away from the negative values right now. We'll get into that in the next one. So we can still do all the same stuff, but we're going to be talking about it in such a different way. You're going to see problems that look like this, where they're giving you a point like, hey, go figure out what sine, cosine, and tangent is of that point x comma y. All right, dude, so I mean, this is going to be the game, and we can have minuses in here. This could both be negative. And we go through and we solve it, and it's going to have to do with sines. But for right now, we'll finish ours. Like we found sine, cosine, and tangent for us, but we'd still be able to go get our cosecant of theta by just flip that shit over. Huh? Secant of theta? Oh crap, just flip over cosine. Cotangent of theta. Hey, 3/4. You know where we're going. So in the next one, we'll actually get into some problems. I was trying to do a little explanation. Hopefully it helped and didn't confuse. I got a little confused when I was talking about it. But yeah, we'll just see much more of how to solve these things. We're going to get to the point, by the end of this section, we should be able to solve sine, cosine, tangent, or anything of our common angles. We're going to be badasses. This is a big one. This is huge. This section, buckle down. I probably said it in all the sections. Whatever. In the graphing, I won't be saying it. I'll be talking shit about the graphing. But for now, come on. Keep going.